Hello and good afternoon to all of you. I hope all of you are doing well and all of you in good health. In today's class, we will be starting with our ninth chapter, that is polymorphism and pointers. Now, to begin with, let us try to understand what polymorphism is. Now, polymorphism basically refers to existence of multiple forms of same aspect of interest. In simple terms, polymorphism means many forms. Now, like we have studied in the previous chapter, inheritance allows you to create a class that inherits attributes and methods from another class. Polymorphism allows you to use these methods in order to perform different operations or different tasks. This implies polymorphism allows us to perform a single action in different ways. Now in C++, there are basically two types of polymorphism, namely these are called as compile time polymorphism and runtime polymorphism. Now, compile time polymorphism can be further divided into function overloading and operator overloading, whereas runtime polymorphism can be explained with the help of virtual functions or function overriding. Now let us try to understand compile time polymorphism. Now, compile time polymorphism is achieved by function overloading or operator overloading. This we have already learned in the previous classes as well. So, C++ allows you to specify more than one definition. Please listen to me carefully. C++ allows you to specify more than one definition for a function name or an operator in the same scope, that is, within the same class, which is called as function overloading and operator overloading respectively. So C++ allow you to have more than one definition for the same function name and operator in the same scope, which is referred to as function overloading and operator overloading. Now let us try to understand what function overloading is. Now function overloading in C++ can be defined as the process of having two or more member functions in a class with the same name but different set of parameters. So function overloading is a process of having two or more member functions in a class with the same name but different set of parameters. So in function overloading, the function can be redefined either by using different types of parameters or different numbers of parameters as per the requirement. So it is only through these differences, that is the number of parameters or the types of parameters, the compiler is capable of differentiating between the two overloaded functions. So the basis on which the compiler differentiates between two overloaded functions are the type of the parameters and the number of parameters. Now let us go through some of the notable advantages of function overloading. Now, function overloading helps us in saving memory. It helps us in elevating consistency and readability of our program. Now, this is one of the most important advantage of function overloading. So it allows us to save memory. It allows us to enhance consistency and enhance readability of the computer program. Now, with the help of function overloading concept, we can have more than one function with the same name. Now, using function overloading concept, we cannot not only have more than one function with the same name, but we can make the functions exhibit different behaviors. Now, function overloading also helps us in speeding up the execution time. This is also one of the notable advantage of function overloading. Now, function overloading also promotes code reusability. So this is one of the other advantage of function overloading, right? Now, it also helps application to load the class methods based on the type of parameters. Definitely, based on the type and the number of parameters, the compiler will decide which overloaded function is to be referred to. And using function overloading, code maintenance becomes very easy. Now let us go through some of the notable disadvantages of function overloading. Now functions that are declared and differs in the return type cannot be overloaded. So function declarations that differs only in the return type cannot be overloaded using function overloading process. So this is an important concept one needs to remember. So function declaration that differs only by its return type cannot be overloaded with function overloading process. Now the second disadvantage is that member function declaration with the same parameter or the same name type cannot be overloaded if any one of them is declared as static member function. So member function declaration with same parameters or the same name type cannot be overloaded if any one of the member is declared as static member function. So static member functions cannot be overloaded and functions with different return type cannot be overloaded. So these are the two notable disadvantages of function overloading. Now let us try to go through function overloading ambiguity. This we have already learned in the previous classes. So if you refer to lectures at the previous classes, you will come across this. So we will simply revisit it. So function overloading ambiguity basically refers to a situation where the compiler is unable to decide which overloaded function to refer to. Right? So function overloading ambiguity basically refers to a situation where compiler is unable to decide which overloaded function is to refer to or to invoke. Right? Now, as we all know, a function overloading ambiguity may be because of the varied reasons like type conversion, a function with default argument, and function with pass by reference. So these are the causes for function overloading ambiguity. So in order to go through it in detail, you can refer to the previous lectures. Now let us try to understand function overloading with the help of an example. So here I have declared a class print data where what I have is I have a public member function, right, or member function that is placed in the public section, right, that is capable of that is called as print, okay, right, and it takes in an integer value I, right, and it prints the value of the integer variable. Likewise, I have another function by the same name print, but the parameter it takes in is of type double, so it takes in a parameter of type double and prints that particular value. Now I have another function print which takes in a character pointer and it prints a string. So now just see here in print data class I have three functions by the same name print, and the return type of all of these functions are void, but the first instance of print takes an integer value, the second instance of print takes in a floating point value that is of type double, and the third instance of print takes a character pointer that refers to a string. Now in the main function, just see here I've declared a object PD of type print data. So PD is first used in order to print the integer value, then it's used to print a floating point value, and third it is used in order to print a string, that is C++ lab. So in today's class what we have learned about is we have learned about what is polymorphism, we have learned about what are the different types of polymorphism? We have learned about compile time polymorphism and runtime polymorphism, and we have learned that under compile time polymorphism, we have function overloading and operator overloading, whereas in case of runtime polymorphism, we have function overriding. We have learned in detail what is compile time polymorphism, and we have learned about what is function overloading. We have discussed some of the notable advantages and disadvantages of function overloading, and then we have discussed function overloading ambiguity, and we have discussed the causes for function overloading ambiguity, and then we have taken up an example in order to elaborate on function overloading. So in the next class, we will be continuing with operator overloading. Thank you very much. Have a very nice day.